Although ATC radar facilities primarily serve IFR traffic, as a VFR pilot, you can request specific radar services. These services provide valuable information, especially in unfamiliar and major terminal areas. As the pilot in command, you're responsible for passenger and aircraft safety, even while you're in radar contact. So it's essential to understand the nature and limitations of these services. Radar, which stands for Radio Detection and Ranging, is a ground-based electronic system that uses a synchronized radio transmitter and receiver to emit and detect radio waves in a narrow beam using a rotating antenna. When the radio waves strike your aircraft, some of the waves reflect back to the antenna. The primary radar system uses this information to display the location of your aircraft on the radar screen. The system calculates your range, or the distance of your aircraft from the radar antenna, by measuring the time it takes for the radio waves to reach your aircraft and then return to the receiving antenna. The radar screen also displays the magnetic direction, or azimuth, of your aircraft from the radar site, based on the position of the rotating antenna when it receives the reflected portion of the radio wave. Although primary radar displays your location on the radar screen, it provides the controller with no further information. Such as your identification, altitude, or speed. To overcome these limitations, ATC might simultaneously use the air traffic control radar beacon system, which is sometimes referred to as secondary surveillance radar or simply secondary radar. This system displays your aircraft call sign, the altitude of your aircraft, and its ground speed. In addition, it indicates whether your aircraft is equipped with a traffic collision avoidance system by displaying the letter T. For ATC RBS to display this information, your aircraft must be equipped with a transponder. The ATC RBS incorporates three components in addition to primary radar: a decoder, which enables a controller to assign a discrete transponder code to your aircraft; an interrogator, which requests information from your transponder; and a transponder, which transmits a coded signal in response. In spite of its capabilities, radar has some significant limitations. Atmospheric temperature inversions can cause anomalous propagation or the bending of radar pulses. If the radar beam bends toward the ground, extraneous returns known as ground clutter can appear on the radar screen. A beam that bends upward reduces the detection range. In addition, heavy precipitation or heavy clouds can produce returns that block out the display of aircraft. Finally, terrain can block radio waves from reaching or returning from the aircraft. In spite of its capabilities, radar has some significant limitations. Atmospheric temperature inversions can cause anomalous propagation or the bending of radar pulses. If the radar beam bends toward the ground, extraneous returns known as ground clutter can appear on the radar screen. A beam that bends upward reduces the detection range. In addition, heavy precipitation or heavy clouds can produce returns that block out the display of aircraft. Finally, terrain can block radio waves from reaching or returning from the aircraft. The FAA operates two basic radar systems: air route surveillance radar and airport surveillance radar. Both of these surveillance systems use primary and secondary radar returns, as well as sophisticated computers and software programs that provide additional information to the controller, such as aircraft speed and altitude. The Air Route Surveillance Radar System, or ARSR, provides long-range information to help controllers manage traffic. Each radar site antenna can monitor aircraft flying within a 200-mile radius of the antenna, with some stations able to monitor aircraft as far away as 600 miles by using remote antenna sites. Approximately 100 ARSR facilities relay traffic information to radar controllers throughout the country at 20 Air Route Traffic Control Centers, or ARTCCs. These centers issue IFR clearances and manage IFR traffic. However, depending on workload, these centers can also provide services to VFR pilots. For example, you might request flight following services, in which controllers provide traffic advisories to you. Because of their extensive radar coverage, centers can provide assistance if you become lost or disoriented. Airport Surveillance Radar, or ASR, provides relatively short-range coverage, approximately 30 miles, within specific terminal areas. Terminal radar approach control facilities, called TRACONs, use this information to ensure safe separation of aircraft transitioning from departure to cruise flight or from cruise to a landing approach. Most ASR facilities throughout the United States use a form of the Automated Radar Terminal System, or ARTS. ARTS increases the number of aircraft that one controller can handle at a given time by reducing the amount of verbal communication necessary between controllers and pilots to relay position information. ARTS equipment automatically displays aircraft position, altitude, ground speed, and other pertinent information on a controller's radar screen. ARTS continuously updates this information as the aircraft progresses through the terminal area. To gain maximum benefit from the system, each aircraft in the area must be equipped with a Mode C or Mode S transponder and the associated altitude encoding altimeter, although this is not an operational requirement. Although radar can detect your aircraft without it, a transponder enhances the display visible on the ATC radar screen. The information displayed depends on the mode of your transponder. Basic transponders operate only in Mode A, which brightens the display and adds your transponder code to the radar screen. Your transponder code may be any of 4,096 different codes. In addition to the basic features, Mode C transponders also provide altitude information to the radar screen. Mode C transponders are required in all Class A, B, and C airspace within 30 miles of primary Class B airspace airports, and any time that you are above 10,000 feet. Mode S transponders have advanced features including the ability to identify your aircraft to other aircraft equipped with Mode S transponders. For example, operation of the Traffic Alert and Collision Avoidance System, or TCAS, depends on Mode S transponder technology. There are other transponder modes, but they're not commonly used in the United States. To use your transponder, follow these steps. Before taxiing to the runway for takeoff, use the function selector to set your transponder to standby. In the standby position, To use your transponder, follow these steps. Before taxiing to the runway for takeoff, use the function selector to set your transponder to standby. In the standby position, the transponder is ready for operation, but it doesn't reply to interrogations. Set the transponder to the code assigned by ATC, or if you're flying VFR, select 1200. A typical transponder can be set to display any number between 0 and 7 for a total of 4,096 possible codes. As late as practical before takeoff, change the mode to altitude or on. Use the on setting only if your transponder doesn't have Mode C capability. If the controller requests it, press ID or ident. Pressing the ident button causes the transponder return to blossom on the radar screen for a few seconds, which enables the controller to establish positive radar contact. After landing and clearing the runway, turn your transponder off or to standby as soon as practical. To familiarize yourself with the transponder controls, click the dials to change the settings on this transponder before moving on. This table lists transponder instructions you might hear from ATC and the actions you should take. Click each instruction to hear an example.
Squawk 1257. Squawk standby. Stop altitude squawk. Squawk altitude. Ident. Squawk 1257 and ident. Squawk low. Stop squawk. Squawk mayday. Squawk VFR.
In cases where your altitude readout differs more than 300 feet from your reported altitude, the controller will issue a Stop Altitude Squawk instruction. This means that you should turn off Mode C, but continue to operate your transponder in Mode A. This condition might mean that your Mode C equipment isn't calibrated properly or that your altimeter setting is incorrect. Be sure to verify your altimeter setting if the controller indicates that your Mode C readout is invalid. Certain transponder codes are reserved for specific situations. The table lists the codes you should be familiar with. Because the emergency codes immediately alert ATC and activate an alarm, you should avoid accidentally dialing through these numbers, even momentarily. For example, if you want to switch from code 2700 to code 7200, switch first to 2200, then to 7200. Don't switch to 7700 and then to 7200. The simplest way to remember this is to avoid entering 7 into the first box as your first step, unless you're going to use an emergency code. Because transponder returns are the basis for radar separation, regulations require that transponders be tested and inspected every 24 calendar months for operations in controlled airspace. The inspection must be done by a radio shop and the results entered into the aircraft logs. In addition, if your transponder has a test button, it's a good idea to verify that all lights are working each time you fly. Radar services for VFR aircraft are usually available from any ATC radar facility, including air route traffic control centers and airport surveillance and radar facilities in terminal areas. The types of service depend on the facility and on how busy the air traffic controllers are, but can include any of the following. ATC radar facilities routinely provide traffic information to IFR aircraft. As the pilot of an aircraft flying VFR, you can request Radar Traffic Information Service, also called VFR Radar Advisory Service, to alert you to air traffic relevant to your flight. ATC radar facilities issue safety alerts to aircraft under their control when, in the controller's judgment, safety might be compromised. For example, you might receive a safety alert if you're in unsafe proximity to terrain, obstructions, or other aircraft. ATC radar facilities might provide vectors to VFR aircraft in certain situations, with the understanding that the navigational guidance information is only advisory, and the job of flying the aircraft safely remains with the pilot. ATC facilities might also provide sequencing and separation to adjust the flow of aircraft arriving into the traffic pattern in a safe and orderly manner, and to provide traffic advisories to departing VFR aircraft. These services may all be included in the Terminal VFR Radar Service Program, a national program extending the terminal radar services for IFR aircraft to VFR aircraft. Check the Airport Facility Directory for any services provided under this program at a given airport.
78 Juliet Romeo, traffic at 11 o'clock.
The purpose of VFR Radar Advisory Service is to alert you to possible conflicting traffic, not to relieve you of your responsibility for collision avoidance. Remember that the controller won't know the altitude of the reported traffic if it isn't equipped with a Mode C transponder and the pilot isn't in communication with ATC. Therefore, the traffic might be well above or below your flight path. After you locate the traffic, tell the controller that you have the traffic in sight and maintain visual contact until it's no longer a factor. If you don't immediately see the traffic, reply to the controller that you're looking for traffic. And if you can't find it, tell the controller negative contact.
"78 Juliet Romeo, low altitude alert. Climb to 5,300 immediately."
Keep in mind that safety alerts depend on the controller's ability to recognize unsafe situations, that uncontrolled aircraft are often involved, and that Mode C altitude readouts are the primary method of detecting unsafe proximity. Safety alerts aren't automatic, although you can request a minimum safe altitude warning or MSAW monitoring if your aircraft is equipped with Mode C. MSAW alerts the controller when an aircraft is in unsafe proximity to terrain or obstructions. The Terminal VFR Radar Service Program has 4 types of services. Basic radar service that includes safety alerts, traffic advisories, and limited radar vectoring. Terminal Radar Service Area or TRSA service. Class B service, and Class C service. Pilots operating under VFR must participate in Class B and C services, but Basic and TRSA services are voluntary, though strongly encouraged.
"78 Juliet Romeo, fly heading 110 until you cross the power lines, then resume course."
ATC might provide vectors if the controller suggests the vector and you agree, if a special program has been established and vectoring service has been advertised, or when, in the controller's judgment, the vector is necessary for air safety. If you have radar vectors, keep the controller advised of the weather conditions along your course. In many cases, controllers cannot determine whether a vector will result in flight into IFR conditions.
78 Juliet Romeo, follow the aircraft at your 12 o'clock position, 4 miles. Do you have that traffic in sight?
Depending on traffic conditions, you can use your own navigation to enter the traffic pattern, or approach control might provide you with routing or vectors for proper sequencing with other traffic en route to the airport. If you report having a preceding aircraft in sight, the controller might instruct you to follow that aircraft. However, you aren't authorized to comply with any instructions issued to the preceding aircraft. When giving traffic alerts, ATC references traffic from your aircraft as if it were a clock with 12 o'clock at the nose. For example, if a controller says traffic at 11 o'clock, it means the traffic appears to the controller to be 30 degrees left of the aircraft nose. You should look for the traffic anywhere between the nose and the left wing of your aircraft, or between 12 and 9 o'clock. However, keep in mind that wind correction angles don't show up on radar, so you need to adjust the controller's advisory accordingly, as this illustration shows. At busy airports, it's difficult and time-consuming for controllers to provide every aircraft with a separate airport advisory, so they use the Automated Terminal Information Service, or ATIS, to continuously broadcast non-control airport information, such as weather, runway, and NOTAM information. By pre-recording this information, they improve controller effectiveness and reduce frequency congestion. ATC changes the recorded message whenever conditions warrant, identifying each new recording by assigning it a successive letter of the phonetic alphabet. You can locate ATIS frequencies on VFR charts, such as sectional or terminal area charts, or in the Airport Facilities directory. The Atis broadcast can be confusing unless you know the information order. Listen to the following Atis broadcast and note the order that the information appears on the screen.
Midway Airport Information Zulu. 1756 Zulu weather. Wind 320 at 16. Visibility 30. 2,500 scattered, 5,000 broken. Temperature 12, dew point 3. Altimeter 2986. ILS runway 31 center approach in use. Landing and departing runway 31. Notice to airmen. Crane 3 miles northwest extending to 850 feet MSL, 230 feet AGL. Advise on initial contact that you have information Zulu.
If the sky condition and ceiling are absent from the broadcast, it means that the visibility is 5 miles or more, and that the ceiling is 5,000 feet or higher. Although you can listen to the broadcast as many times as necessary, you might find it helpful to write down the ATIS information. For helpful shorthand tips, click More Information. You probably won't be able to copy the ATIS word for word unless you listen to it several times, but you can get the important information if you use a piece of paper with these headings along the left side. Then, using abbreviations for the items listed, you can easily fill in the blanks on one pass through the ATIS.
Gary, Chicago International Information Bravo, 1355 Zulu weather, wind 310 at 12, visibility 10, 4,500 broken, temperature 18, dew point 10, altimeter 2982, ILS runway 30 approach in use, landing and departing runway 30. Notice to airmen. Numerous birds on and in the vicinity of the airport. Advise on initial contact you have information Bravo.
You can review other shorthand abbreviations in the Key to Aerodrome Forecast and Aviation Routine Weather Report figure in the Aeronautical Information Manual, Chapter 7, Section 1, Paragraph 22.
Houston Hobby Information Alpha, 1955 Zulu weather, wind 290 at 15, visibility 10, 3,300 broken, temperature 15, dew point 8, altimeter 29907, ILS runway 30 left approach in use, landing and departing runways 31 and 35. Notices to airmen, numerous birds on and in the vicinity of the airport, runway 30 left, DME out of service indefinitely. Advise on initial contact. You have information Alpha.
Flight service stations developed from the radio stations that were established along airmail routes in the 1920s to provide weather information to pilots. Today, there are two types of flight service stations in the United States. Automated flight service stations, abbreviated AFSS, are facilities that provide a variety of services to pilots, including weather services such as weather briefings, collecting and disseminating pilot reports on weather and flight conditions, and broadcasting aviation weather and airspace information. Search and rescue services, as well as assisting lost aircraft and aircraft in emergency situations. Flight plan services, such as filing, activating, and closing flight plans, and advising customs and immigration of transborder flights. En route services, such as facilitating en route communication, providing en route weather service, and relaying ATC clearances. And additional services, such as originating NOTAMs, issuing airport advisories, and monitoring navigational aids. Private contractors operate AFSS facilities for the federal government. The second type of flight service station is operated by the FAA itself. These facilities, abbreviated FSS, provide all of the services of an AFSS, plus some additional services. The remaining FAA-operated flight service stations are all in Alaska. When an FSS is located on an airport, it provides local airport advisory service to pilots when there is no control tower or if the control tower is not operating. The FSS even provides a service like Atis at some airports. Vhf Direction-Finding is another service available at some facilities. Stations equipped with DF equipment can help orient lost pilots and determine their position. The only equipment needed in the aircraft is a two-way VHF radio. This service is particularly helpful in areas where there is no ATC radar coverage. However, it's being replaced by newer technology like ADS-B and GPS. Air route traffic control centers and automated flight service stations alert the search and rescue system when they receive information from any source that an aircraft is in difficulty, overdue, or missing. Federal and state agencies jointly provide this life-saving service. Usually, the Civil Air Patrol, a civilian extension of the U.S. Air Force, assists in search and rescue operations. Flight plan information is invaluable to search and rescue forces for search planning and for carrying out search efforts. You should make occasional position reports so that the flight service station has an idea of your last known position if you don't arrive at your destination. Although the FAA doesn't require VFR pilots to file flight plans, doing so enables search and rescue teams to locate you more quickly in the event of an emergency landing. Filing a flight plan with an automated flight service station generates a record that includes your destination, route of flight, arrival time, fuel endurance, color of your aircraft, and the number of people on board. After you're airborne, open your flight plan so the station can keep track of your estimated arrival time. If you decide not to proceed to your original destination, or if you're going to be more than 15 minutes late, inform the nearest flight service station. Close your flight plan within 30 minutes after arrival, because if you haven't closed or canceled your flight plan within 30 minutes after your estimated arrival time, the flight service station might initiate search and rescue procedures, and you could be liable for the costs. You can find the frequencies for automated flight service stations throughout the U.S. on sectional charts, terminal area charts, and in the airport facility directory. Address the station by the name printed under the frequency box on the sectional chart or listed in the AFD. In addition, you can contact the station by telephone or on the Internet. But keep in mind that if you call on your mobile phone, your call will be directed to the flight service station closest to your local area code, not to the station for the region you're in. In this lesson, you learned about the ATC services available to you by exploring these topics: radar, transponder operation, VFR radar service, automatic terminal information service or ATIS, and flight service stations.